A lot of people overhype AI without understanding the technical details. Despite what many politicians, influencers, and CEOs are telling you, AI will always have severe technical limitations. I'm going to show you a basic task that ChatGPT, Claude, Gemini, and Perplexity all do raw. Then I'll show you the intuition behind how these models are built. Once you understand the intuition, it becomes obvious why they all fail this simple task and will always struggle with it. You'll get a sense for the problems where AI can shine versus where it's bound to fail. Anyone who has taken CS 101 can write a program to multiply two numbers. But what if we ask one of those general-purpose AIs to do multiplication? Here's a prompt. What is the product of these two random-looking numbers? Here's the correct answer by Wolfram Alpha, which is a calculator and not an AI. And here we can see Claude Sonnet 4 gets it wrong. ChatGPT also gets it wrong. And finally, Gemini and Perplexity also get it wrong. AI supposedly can pass law exams, do PhD research, and drive cars. But it can't use a calculator? To understand why, let's dive into the technicals of how AI modeling works. I'm going to explain in beginner terms, so anyone can understand. Whatever our problem, whether it's multiplying two numbers, getting a car to drive itself, or a general-purpose AI, there exists some program out there to do it correctly. Or may train an AI model, we're searching for that program. There's an infinite monkey theorem saying if you have infinite monkeys typing randomly on a keyboard, eventually one will produce the complete works of Shakespeare. And in our case, if you have infinite monkeys coding randomly, one will write a program that multiplies two numbers eventually. In the AI research world, we deploy a lot of monkeys typing out programs. Billions of dollars of funding buys a lot of computers, aka monkeys, churning out random programs 24/7. To test if a randomly generated program is correct or not, we enter some inputs and check the outputs. We can't list all possible inputs and outputs, but we can cheaply hire people through Amazon Mechanical Turk, Scale AI, and etc. to write millions of them. Finally, the program with the most correct outputs and highest score on our millions of tests gets shown to users. But it's just randomly generated gibberish that happens to work. We cannot understand anything in the black box. Things not captured in our millions of tests are prone to error. When I asked the AIs to multiply those random numbers, they failed because my numbers weren't in a test. Tests can never cover all multiplication problems, so AIs will always miss some multiplication problems. That's AI modeling in a nutshell. The big technical detail I glossed over is there's a ton of super smart people who made the guessing game way better than monkeys randomly typing. And they developed methods to get the final program to generalize well, beyond the initial set of test cases. I'm not going into depth on these topics today because they require a ton of technical knowledge. Just know you should respect all their hard work because most of us, myself included, don't have the smarts to come up with models performing that well. The key takeaway for this video is that models are limited by their training data, and you cannot generate training data to capture every scenario. This has a lot of consequences for what AI can and cannot do. Now that you have a better idea of how AI models are built and why they struggle with multiplication, think about all the potential use cases for AI and whether you would want to use them. Comment your thoughts below. I promise I'm not using them to train my AI. And I'll talk about some of these scenarios in future videos, so be sure to stay tuned.